Lesson 3 is on linear functions and proportionality. So let's just think a little bit about these two terms, linear functions and proportionality. The first thing, when we talk about linear functions, we're talking about y equals mx plus b. So if you remember, m right here, that's our constant, or we would refer to it, sorry about that, as slope. Gonna have my stylus problems again. Oh goodness, that's slope. Let's see if I can do better. I know how I can do better. So that stands for slope, or represents slope, I should say. So just using an arrow now. The m is slope. And then we want to keep in mind that our b, and this is going to come into play later, is our y-intercept. So our y-intercept goes with our b here. Okay, so if you think back, long ago we talked about proportionality, and we had a similar equation. But this y equals kx, so it's kind of like the y equals mx right here. But instead of thinking it in terms of slope, well, we thought about it in terms of being a constant. So our k was what we called our constant. And our slope and our constant basically are the same thing, just talking in like different situations. Okay, so now let's, as that review here, let's take it into this example of how we're going to put linear functions and proportionality together. Remember proportionality, there's a constant we're multiplying by the same number every time, goes through 0, 0. Linear function, multiplying by the same number each time, but it doesn't go through 0, 0. So don't worry about this last lesson part. It says we looked at tables of values, inputs and outputs, which we've done before. So if you remember, bags of candy, that's going to be our inputs, and the cost is our output. So however many bags of candy, our outputs are dependent on how many bags of candy. What the cost is dependent on the bags of candy. Okay, so if we look at this, one bag of candy costs $1.25, 2 bags of candy cost $2.50, and you should see that it's increasing by the same constant every time. So if you remember, when we were doing this before, we always do y over x, okay? Outputs over inputs, y over x, and then we set it equal and we take one of those ratios. So we have y over x equals $1.25 over 1. And that was how we were like kind of doing those distance and time things. Now let's see if I can do this for us. And we remember how we solved this was we would do the butterfly method, I think we called it. Ooh, I don't know if that's going to work. Sorry, not going to work. We're going to have to use the stylus. All right, so we're going to use the butterfly method. And what we would do is slowly, unfortunately, we would take our cross products. So 1 times y. Doesn't like my stylus being lifted up here, apparently, huh? So we would have 1 times y equal to, and then we'd go x times 1.25, or 1 point, I was so close. One point 2.5 times x. I'm so sorry, guys. Okay, so solving this, remember we would divide both sides by 1, but that's not going to do anything. So we get y equals 1.25x. 1.25 times x. There we go. So remember, our y here is our cost. Maybe. And our x is the number of bags of candy. So y is our cost. So the cost equals 1.25 times our bags of candy there to the x. So this is a proportional relationship because we are multiplying by 1.25 every time. 2 times 1.25, 3 times 1.25, and so on and so forth. Okay? But it's also a linear relationship. Think about it. If you buy 0 bags of candy, it costs $0. So in this case, it would be both. Let's look, and again, our focus today is on both linear functions and proportionality. So let's look at one more example in this. It says Walter walks at a constant speed. You've heard me talk about constant speed before. We're thinking being proportional. Of 8 miles every 2 hours. So this is like kind of when we were doing that distance over time thing, or y over x. So our y over x equals 8 miles over 2 hours. So if it says describe a linear function, proportionality here, remember we do 2 times y equals 8 times x. Okay, so then to solve this, remember we always solve for y. That's in some of your notes somewhere along the way. We're going to divide both sides by 2. And this is going to frustrate me. I'm going to work on getting some better technology here. Divide both sides by 2. I'm going to get good doing this with my mouse. So 2 divided by 2 is 1y. That's a poorly written y. And 8 divided by 2 is 4. So we have 4 times x. So again, remember our y here goes along with the miles. And our x goes along with the hours. So y represents miles, and x represents the number of hours. So the number of miles Walter walks is dependent on the number of hours. And from that, we could do an input-output table. So remember, if we walked 0, or Walter walked 0 miles, it would be 0 hours. That's why this is going to be of a constant, and it goes through 0, 0. This would be proportional. So we've really been doing linear functions the whole time we've been doing proportionality. So again, if 1 mile, 1 times 4 is 4. 2 miles, 2 times 4 is 8. Move that out of the way there. We could pick 10. If it was 10 times 4, it'd be 40. What if it was 1.5? There's nothing saying that we can't walk a partial mile, or I'm sorry, walk for a partial hour. And so if we did 1.5 times 4, we'd get 6. Okay, so a lot of what we've already been working on is linear functions. We were just talking about it in terms of proportionality.